So for problem 23, we're given this pair of parametric equations here. And what we want to do first is eliminate the parameter to obtain an equation in x and y. So we have that x is equal to cosine of t and y is equal to 1 plus sine of t. So the way that we're going to eliminate the parameter is by using this identity here where sine squared plus cosine squared is equal to 1. So we only have cosine and sine, which means that we need to square the equations. So for the x equation, we have x is equal to cosine t, and when we square that, that's just x squared is equal to cosine squared of t. And then for the y equation, I'm first going to bring the 1 to the left-hand side. So we're given y minus 1 is equal to sine of t, and now I'm going to square both sides. So y minus 1 squared is equal to sine squared of t. So once I have my cosine squared and my sine squared, I can now add them. So I'm going to add these two equations. On the left hand side, I get x squared plus y minus 1 squared is equal to cosine squared t plus sine squared of t. But however, because of this identity here, we know that when we sum the squares of sine and cosine, we just get 1, so that's equal to 1. So right now, we have the equation x squared plus y minus 1 squared is equal to 1. So if you compare it to the equation of a circle, so x squared plus y squared is equal to r squared, what we can see here is that the equation that we got is actually a circle. However, the y coordinate has been shifted to the right by 1 unit, and the radius is equal to 1. So this equation over here, this describes it is a circle centered at, so the x coordinate just stays in the origin because that has not moved, but the y coordinate has. So it's centered at 0, 1 with a radius of 1. So we know that our parametric equation, when expressed in x and y, gives us the equation of a circle centered at the point 0, 1 with a radius of 1. And all that's missing for us now is to indicate the positive orientation. So where does this circle begin? Well, the parameter t, it begins at 0. So what we have to do here is we have to plug in t is equal to 0 into x and y equations to find the starting point on the x and y plane. So when t is equal to 0, we're going to plug that into the x equation. So x is equal to cosine of 0, which is equal to 1. And y is going to be 1 plus sine t, so 1 plus sine of 0, which is equal to 1 plus 0 is just 1. So we can, our circle is going to begin at the point 1, 1. So we can say it begins at the point 1, 1. And then the positive orientation, well, t goes from 0 to 2 pi. So let me maybe graph that in. So we have 1, 1, 1, 1, and then 2, 2, 2, 2. So our circle is centered at this point 0, 1, and the radius is 1. So it means that it's going to go around like this. So this is what our circle looks like. So the beginning point is the point 1, 1, and now because the parameter t goes from 0 to 2 pi, and t is positive, right? So whenever we have a positive angle, it's just going to go around clockwise from the angle theta is equal to 0 all the way out to 2 pi. So it's just a circle that has been shifted upwards 1, but it goes counterclockwise around for a full revolution. So it begins at 1, 1, and it goes counterclockwise for a full revolution. And we know that it's a full revolution because the angle goes from 0 to 2 pi, and a circle has 2 pi in it, right? So that is it for problem number 23.